From Chicago, welcome to 3 Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
When I saw the MJF machine, I was like, oh my God, that's it. There it is. That is the machine that connects the dots between the economics. I can produce parts cheap enough, they're rugged enough, and we don't have to deal with supports. We don't have to deal with a bunch of post-processing. And I saw that machine. I said, this is the machine that is going to unlock additive for the shop floor. And so I went and borrowed all the money. I took all my money and then I went and borrowed a ton more money and I pushed it all into MJF, and I got that shiny new MJF machine in here and I was so proud. And I'll never forget, I walk into the office of an engineering manager at one of my very first machine build customers. I walk in there and I'm like, dude, you're never gonna believe what I got. And I handed him a little like gear toy that I designed up. I said, this was printed as a single piece. This isn't an assembly. And I was expecting him to be like, oh my God, this is incredible. And he looks at it and he looks at me and he looks back at it. He's like, how strong is it? And I'm like, I brought the HP data sheet. It's right here. Look at this. It says right there in megapascals how strong it is. He goes, I don't know what that is. He's like, quantify that for me. I'm like, well, it's on the sheet. I don't have to quantify it for you. He's like, I don't know what that means. I'm like, oh my God, okay.
That was Paul DeWys. Paul is a self-described sales guy trapped in the body of an engineer who ended up in marketing, hence his role as a sales engineer. He works with companies and customers to help educate them about what is possible when you combine 3D laser scanning to capture a part, apply mechanical engineering expertise to modify it, and use added manufacturing equipment to help prototype or produce end-use parts. He does this through his companies DeWys Engineering and Forerunner 3D Printing. For today's show, he shares his experience building a 3D printing company from scratch and his advice for communicating the technical information related to 3D printing materials, machines, and processes. All right, Paul, welcome to the show. Do you want to just start by giving a little intro for the audience?
Sure. So my name is Paul DeWys. I am the owner of Forerunner 3D Printing and DeWys Engineering. We're a full service additive manufacturer. Also have a full engineering, mechanical engineering group as well. So we're kind of a hybrid of both additive and engineering, among some other things.
So was additive the first type of technology that you started with in your shop, or were you kind of doing other sorts of industrial manufacturing?
So I guess a little bit of history. So let's see. So back in 2008 timeframe, I was going to college. I'd done an associate's in manufacturing tooling, which is essentially tool and die school. A lot of CNC, EDM, lathes, just everything. Essentially, everything you need to know to design and then build injection mold stamping dies, stuff like that. And then when I got into my, and that whole program was based in a CAD software called CATIA V5 from Dassault. And so I realized pretty quickly I was an absolutely terrible machinist, but I was an incredible CATIA guy. I broke more stuff in that machine shop. Oh my goodness. So, but I could program with the best of them. So, I would program. My friends who were incredible machinists, they would run the program. Everybody would win. So I started kind of find my lane my first 2 years of college. And then my second 2 years of college, I rolled that into a bachelor's of manufacturing engineering. And within about a month, I realized that the last thing I want to do for a living was be a manufacturing engineer. But I was in the program and I was young and naive and didn't realize that you could just change degrees. I just was like, well, I'm in it. I got to finish it now. But I continued on with my kind of CATIA related activities. And what happened is I ended up getting hired to be a CATIA lab tutor at Ferris. And pretty much what that boiled down to is kids would just pay me, usually in beer, to do their CATIA work for them. And so I had a thriving CATIA business where I was paid in Coors Light in college. And that got me thinking. I was working at a tool and die shop on my Friday. I didn't have Friday classes, and I would work there every Friday, and then Christmas, summers, things like that. I'd work there starting in 2007 or maybe 2008. Anyways, so that got me thinking. I wonder if these kids are willing to, essentially buy me beer to do their CATIA work, I wonder if I could get companies to pay me money to do their CATIA work. Revolutionary thought. And so the kind of the end of that summer of 2008, I'm sorry, it would have been the end of summer 2009, which would have been between my junior and senior years. I had Friday classes my senior year, so I couldn't come down and work every Friday. And so I'm sitting there talking to my boss in probably like July timeframe, and I'm like, he's like, hey, you're going to be working Fridays again this school year? I'm like, nope, not this school year. I got Friday classes. And he's like, oh, that's too bad. We won't have someone to give all the terrible work to. Because that's what I did. I was just, crap rolled downhill, and my desk was at the bottom of the hill. So anything that no one else wanted to do, bam, landed on my desk. And I was, the low man on the totem pole. You can't say no. You're just happy. Heck, it's 2009. I was just happy to have a job in manufacturing. And so he said, yeah, it's too bad. We don't want to give all the crappy work to. And that got me thinking, I wonder if these guys would hire me remotely from school. So I kind of did an experiment. I just listened to the 4-hour work week, and that was all in my head. And I thought, I'm going to take a day and I'm going to see if I can not leave my cubicle for a day and still effectively do my job. So for one random Wednesday, I did not leave my cubicle for the entire day. I did everything over email and phone calls and IM. And I actually was probably about 15% more efficient than I normally am, because you're not talking to coworkers and you're not screwing around, right? So I thought, okay, that's interesting. So I went to my boss and I said, hey, I told you I can't work Fridays, but what if you guys hired me from school to work remotely? I said, I did this experiment and I was more productive. I think I could be just as productive from school working remotely as I could be from here. And my boss, he kind of, thinks about it, and he goes, well, if you go pitch this to the big boss, this company, it's a wholly owned subsidiary of one of the big three. At one point in time, it was the largest tool and die shop in the world. So it's quite a big facility, and the guy in charge was had quite a reputation. We'll put it that way. And so he goes, you got to go pitch him, and if he agrees, then we can do this. And I go, oh, okay. So I jump on the elevator and I go up to the third or fourth floor of the building. I've never even been up there, and over the lunch break, and I get off the elevator, and it's like in a movie. It's like a long hallway, and the lights, there's no one up there, and the lights are on like motion sensors. So as I was walking down the hall, it's like click, click, click. And they're like shutting off behind me. I'm like, holy crap. And so I make it to a secretary, and I'm like, hey, I'm here to see so-and-so. She's like, do you have a meeting? I'm like, no. I'm like, I'm just the intern from the engineering department. She's like, oh, he's eating lunch. You can go talk to him. I'm like, okay. I walk in, there's this guy. He's sitting at his desk. He looks up. He's like, he looks up and he looks at me and he goes, what? And I go, hello, sir. My name is Paul DeWys. He goes, I know who you are. I'm like, okay, that's great news. I didn't think you knew who I was. Anyways, my boss said that he would hire me to work from, Big Rapids, and he said I had to come up here and talk to you, and if you said it was okay, he'd say it was okay, and then I could get hired. And Dennis goes, I don't care. And I go, so like we could do it? He goes, if the other guys, if your boss says it's fine, I don't care. And I go, great. Let's turn around on my heels, walk back out. Get on the elevator, go down. I'm like, go to Mike. I'm like, Mike, you're never going to believe it. He said it would be okay. And Mike's like, you actually went and talked to him? I'm like, yeah. He's like, oh, I didn't think you'd do that. I'm like, yeah,
he's just hazing you a little bit.
So anyways, so that was my first customer. I got a hold of a seat of CATIA V5, and they were customer number one. And from summer 2009 through to summer of 2010, I made just enough money to pay off my seat of CATIA. So I didn't really make any money, but I came out of school with a seat of CATIA and a laptop that could run it. And so I thought, okay, I'm moving back into my mom's basement. My student loans don't kick in for 6 months. I wonder if I can get 2 customers, because one customer wasn't going to cut it. I had to have more customers if I wanted to live. So through that summer of 2010, I managed to get 2 more very small customers, and I also got a seat of SolidWorks as well, because I realized there's like 20 companies in the world that use CATIA, and 3 of them are automotive companies. So if I wanted to grow my business, I couldn't just be CATIA. I had to be beyond that. So got into SolidWorks, and from 2010 up until about 2013, just grew my engineering business. Really specialized in factory automation, so assembly lines and automated assembly equipment, and then also got into agricultural equipment, things like that. Just pretty much, I didn't say no to anything. If it was like, oh, there's money associated with this, and sometimes even if there wasn't money associated with it, I'd be like, great, I'm in, let's do it. So went and then in 2013, I'd hired a couple of people at that point in time. So I think there was 4 of us at that point. And we were doing a lot of product development that year. We picked up a couple of customers doing cell phone cases. And so I had a company. So we're between Grand Rapids, Michigan and Lake Michigan, about halfway. And just to the north of us, there's another city called Muskegon. And in Muskegon, there was a 3D printing company called Select Manufacturing. And Select is a kind of a fascinating story. So this guy, Ross Gates is his name. Ross saw one of the very first SLA machines at a trade show, like in 92 or 93. I mean, like way early, when it was just 3D Systems. And he saw it and he said, you know what, there's a business here. So in 1994, he actually bought his first SLA 250 from 3D Systems, and set up shop in Muskegon, and built over the next, probably 15, 20 years, built a nice additive, small additive manufacturing shop. When the kind of the big crash in 2008 hit the manufacturing market, it really kneecapped him pretty bad. And so he had to downsize quite a bit. So in 2013, when I was dealing with him quite a bit, it was him and a bookkeeper and a couple of 3D printing techs, and that was it. And he had a SLA 500 and SLA 5000, and then an old blown up his old 250 still sitting there too. So all SLA equipment. And Ross loves to talk, and I love to talk. So what would happen is I would go in there to pick up my parts, and like we would just sit there and just shoot the shit for an hour. And after probably 6 months of like every 2 weeks I'm in there picking up parts and talking. One day he's in there and he's like, oh, my daughter just bought a house out on the East Coast, and I want to go visit her, and my wife wants to go visit her and see their new place, but I'm stuck here with this business. I can't leave. The 3D printing business. It's if you're not there, nothing's happening. So and I kind of was like half joking. I'm like, oh, Ross, I'm like, you should sell me your business. Like that, I'd buy this business from you. And he's like, well, maybe I will. And I was like, uh-oh. And I go, okay, let's talk. So I quickly run home and I Google how to buy a business, because I had no idea what I was doing or how to go about doing it. And I've always been a big fan of, trying to have mentors. So, anytime I can like somehow like ingratiate myself with like somebody, I kind of stick in my Rolodex, and they're nice enough to pick up the phone when I call. So I had a guy that I knew who'd done a lot of M&A of like, medium to small size businesses. And so I said, hey, can you come with me? I have no idea what I'm doing. Like, I don't know what to do here. So we went and we talked to Ross, and like I said, this is about probably 2013. And it was pretty obvious he wasn't really ready yet. He wasn't quite there mentally. So I said, you know what, Ross, like, no big deal, dude. Like, just, you got my number, call me. When you're ready to sell it, just call me. And so that was 2013. And then literally 2 years later, spring of 2015, I'm sitting at my desk, and I was in the middle of actually building out. We'd grown beyond our little office that I started in. There was like 5 of us in there at that point. So I had an opportunity to build out a space in a building down the street. And so I was just getting ready to build out the space, and my phone rings, and it's Ross Gates. I'm like, oh, I haven't talked to Ross in like 6 months. And I pick up the phone. I'm like, Ross, how's it going? He's like, I'm done. I'm sick of it. I'm selling it. Do you want it? And I'm like, good to hear from you, Ross. Let's talk. So I turned around to my engineering manager and I said, hey, man, I'm going to see Ross. I could be gone an hour. I could be gone the rest of the day. I have no idea. I'll let you know what happens. So I shoot out to Muskegon, and we sit down, and Ross just kind of had a rough couple of weeks, and just, he was 67 or 68 years old, and he just was like, I've had enough. And so we went and we talked, and we got a deal done for me to buy the assets of his company. And essentially I bought his machines and his customer list. And then I hired him as a contractor for 3 months to teach me the ropes. And yeah, we got the deal done in like essentially a week. And I called up my guy who's doing my construction. I'm like, stop. We got to completely redo the plan. I got 2 SLA machines I need to find space for. So yeah, we got our SLA machines in here. And so I still had and still have my engineering business. And so I didn't just want to roll the assets into DeWys Engineering. I always a big fan of like, having different business units. So it's like, let's start a new business unit specifically for 3D printing. And so that is where Forerunner 3D printing came from, was, it's all the same people. It's all, owned by me, but we just break it up into a couple different business units just to keep things a little cleaner for, some customers only need printing, some customers only need engineering. That's kind of how that all shook out. So yeah, so there's a very long answer to your question of how I got my start in additive manufacturing.
That's awesome. And so as you started the 3D printing business, did you start with a customer list, and was there a lot of overlap between your engineering business as well, or what? How did you end up growing that, or did that change?
So I kind of skipped over a little part. So early on in my engineering business, we actually got a ferro arm with a laser scan head on it, because we kept having our foundry and heavy industry customers call us up, and they'd be like, I got a gear and I cracked a tooth off it. And you'd show up, and it's like a 3-foot diameter Sandmuller gear, and it's shattered into like 600 pieces, and it's got like a helical gear tooth. And you're like, you can get this within like 2 thou. And I have like a tape measure and calipers, and like that's about it. I'm like, no, man, I can't, like, this isn't magic. There's not like a button in SolidWorks just says like new gear. Like, yeah. So we got a ferro arm, and what I realized when I got that ferro arm was there was a whole bunch of work out there just for the ferro arm, but it would help get me, into customers where I could cross sell. So we might go in for ferro reverse engineering work, but then while I'm in there, maybe we start talking, and you're like, man, we're so buried in engineering. And it's like, hey, if you need help with engineering, we do that too. And it worked like magic. Like, I was like, what? This is crazy. Like, there's this cross-selling opportunity. And so with 3D printing, I kind of had the same idea, because my engineering business, we were using 3D printing, and we had like a MakerBot and stuff. We were doing a little bit in the office, but I thought, we'll need this capability going forward. It's only going to get more and more. But my thought was, a ton of my customers probably need this too, even if they don't realize it. And if I have it in house, it makes it a lot easier for me to cross sell it versus trying to say, oh, well, I've got this guy I work with. And, there's something about having it all in one place that just seems to like unlock opportunities. And so yeah, obviously, like Ross's customer list, there was people in there that I'd never met before, I've never talked to before, and he'd been around since '94, so he had some really big companies that he was doing business with. Unfortunately, he pissed a lot of them off, because he kind of stopped giving a shit in 2010. So his customer list wasn't nearly what I'd hoped it was going to be. I got a lot of hey, this is Paul DeWys. I know you used to do business with Select Manufacturing. Like, we don't do business with Select Manufacturing anymore. And it's like, no, I'm the new guy. I'm not Ross. Please, for the love of God, let me talk to you. So yeah, but what ended up happening is there was an incredible, and to this day, there continues to be an incredible amount of our engineering customers who need additive. And now we're seeing a ton of our additive customers who need engineering, specifically designed for additive type engineering. And what's really exciting is, you know, I as I've been building this engineering company, I mean, there's engineering companies that are known for tool and die. There's engineering companies that are known for automation. There's engineering companies that are known for product development. And I always looked at those guys and it's like, man, they've been at this for like, 20, 30 years. They've built up this reputation. People know to go to them. I wish I could find a greenfield type environment where I could be the guy of something. And what we found was additive manufacturing. We're in like this crazy time frame right now where like everything is moving from like the days of like it's a prototype or it's a one-off to like now like low volume manufacturing. And what we have found, and it's not like some big massive insight here, but like, hey, if you design for the additive manufacturing process, you can really unlock some cool things around not only the capabilities of your parts, but the economics of your parts. One customer I can think of in particular that we have, they manufacture composite manhole covers. And they have to make a lockable version of these manhole covers if they're covering up like high power, like underground vaults where they have like big power buses and things like that. They can't just leave those unlocked. And so, they might only sell 30, 40 of these manhole covers a year with a locking mechanism on it. And so they were about to go drop, 20 grand on an injection mold to make these brackets. And we were doing the engineering on the brackets for them. And I'm like, guys, like we could print this for you. And I'm like, I won't be able to get to that magical $1 per part number that you're used to with injection molding, but you don't have $20,000 that you're spending up front. And, we can do some cool stuff that you couldn't do with injection, or at least you couldn't do cost effectively with injection molding. But, you got to give me the freedom to redesign this the way I want. And we went from, we could get 35 of the original injection molded brackets into a single MJF build. And when we were done, I think we were over 150 of these in a single build, just because we designed them to stack and to nest in there. And the customer, they bought them and they bought a full build. And now once a year, they order a full build of those parts for us. From us, and they love it because they're like, this is great. I mean, they're like, we would have bought this tool and the injection mold shop would have had a minimum order quantity of like 2,000. They're like, we probably would have never used 2,000 of these. It's so low volume. So that's the really cool thing that we're seeing is because we have such a robust engineering group in-house and because they're used to designing for additive because we've been doing it since 2015, we've found that it's brought us opportunities because of that.
I'm sure as someone that has both the engineering and the machines in-house, there's a lot of, I'd say competitors or other people in the space that they're just a job shop. You'll give them your design and you'll get back what you get back. And it may not be designed optimally, but I imagine that capability to say, wait a minute, like have you thought about it this way, or being in kind of customers' meetings and seeing the parts from your engineering business, like you have the context, which I think a lot of people certainly in the heritage of prototyping and some of the standard service bureaus, like you never had the context. Like if you knew what it was or what it was going to do, there's probably so much more you could optimize if needed. Yeah.
And like one of the things that, one of the things I had to figure out early on in the additive manufacturing world is, look, if your customers are interested in only lowest price, you're never going to beat Xometry. You're never going to beat 3D Hubs. You're never going to beat, any of those guys. Like they are always going to be the low cost provider. And that's fine. Like, great. That we need, the industry needs that. But what I've found is a lot of my customers that have tried to push the boundaries of additive have run into a situation of if they're just using the low cost provider, there's no control, there's no consistency, and they might get great parts one time, and then the next time they get garbage. And they also, let's say they want to try something, let's say they've got some crazy idea that they want to try, they're just dealing with a quoting engine. They just put their part in there and they're like, okay, I hope I can get back what I want. Or they have questions. I mean, yeah, there's great resources pages, and yeah, there's even sales engineers that you can talk to. But in our experience, what really sets guys like us apart is like, you come to us and you're dealing with a guy who does this day in and day out every day. And not only do we, me and my guys, not only do we know the machines really, really well, we understand what you're trying to do, okay? Because we also design products and design machines. So a great example of this is a huge portion of our business is supporting what I like to call like shop floor additive. So Stratasys and 3D Systems forever have been talking about like shop floor jigs and fixtures, jigs and fixtures, jigs and fixtures. Well, there's so much more opportunity out there than just simple jigs and fixtures. And what we found is a lot of our machine build customers, because we have a 10-year history of designing automated assembly equipment, what we found is a lot of our machine build customers were super leery about using any 3D printing because they'd been burned. Like from what I can tell, a lot of the large 3D printing OEMs, I'll leave the names out, but you can probably guess what I'm talking about, had rolled into these places, in 2007, 2008, kind of at that like hype peak moment when like MakerBot was like going to change the world, and 3D printing, everyone's going to have a 3D printer in their closet. And they came into all these shops and they said 3D printing is the answer to all of your problems. Doesn't matter what the problem is, the answer is 3D printing. And all these shops are like, great, we've been looking for the easy button. Here it is. And it's just not true. It's not true at all. And so all these applications failed, and additive got a black eye. Like everyone was just like, oh, we tried that. It doesn't work. It can't work for us. So this leads to kind of what we were talking about a little bit before we started the podcast here. I produce a lot of videos. I produce a lot of content, on our website. And the reason I do that is because my customer base is so skeptical of additive. I mean, I have the most skeptical, I would argue I have the most skeptical customer base in the world, because it's these machine builders. And I remember when I saw the HP MJF for the first time, I'd only been running, SLAs up to that point. And when I saw the MJF machine, I was like, oh my God, that's it. There it is. That is the machine that connects the dots between the economics. I can produce parts cheap enough, they're rugged enough, and we don't have to deal with supports. We don't have to deal with a bunch of post-processing. And I saw that machine. I said, this is the machine that is going to unlock additive for the shop floor. And so I went and borrowed all the money. I took all my money, and then I went and borrowed a ton more money, and I pushed it all into MJF. And I got that shiny new MJF machine in here, and I was so proud. And I'll never forget, I walk into the office of an engineering manager at one of my very first machine build customers. I walk in there and I'm like, dude, you're never going to believe what I got. And I handed him a little like gear toy that I designed up. I said, this was printed as a single piece. This isn't an assembly. And I was expecting him to be like, oh my God, this is incredible. And he looks at it and he looks at me and he looks back at it. He's like, how strong is it? And I'm like, I brought the HP data sheet. It's right here. Look at this. It says right there in megapascals how strong it is. He goes, I don't know what that is. He's like, quantify that for me. I'm like, well, it's on the sheet. I don't have to quantify it for you. He's like, I don't know what that means. I'm like, oh my God. Okay. So I like scramble back to my office, and I had a misspent youth filming and editing snowboard videos. And so when I was a kid, I was never athletic enough or especially skilled enough to do anything exciting on a snowboard. But man, I could hold that camera, and man, I could get in there and edit videos. So I spent, a whole childhood and young adult filming. And so I thought, all right, I'll make a video of like a pull test. Like we'll build a pull tester and I'll pull test these parts to show what, 48 megapascals actually equates to in the real world. And so I held my camera, and my engineering manager, Nick, was over there. And it was literally our first pull tester was a old Lumber Liquidators butcher block countertop, a winch off of a boat trailer, and some pulleys. And then we printed, one of my other machine builders had asked me, hey, I said, look, you can print threads. And he's like, great, what's the pullout force on those threads? I'm like, I don't have any idea, but let me find out. So we printed these test bars. And first video is Nick over there, and he's like got like safety glasses on. And he's just like, oh my God, and literally cranking this thing. And we got the 1/4-20 sample to break at 250 pounds in tension. 3/8 broke at 350 pounds in tension. 1/2 inch, we broke our pull tester at 650 pounds. Then we rebuilt our pull tester and broke that one at 900 pounds. And I cut that video together, and I sent it to that machine build guy. And the next day I had an order, and I was like, unlock. Okay, so if these guys are skeptical, prove to them it'll work, and they'll buy parts from you. And so literally every video or every piece of content that we produce, it starts from me doing a lunch and learn, and one of these guys raising his hand and going, what do you do for if you need something that's electrically, that's a ESD safe that can dissipate static electricity? And I go, I don't know, but let me get back to you. And then, I go and we do a video around ESD safe coatings and options in FDM for ESD. Because don't get me wrong, I love MJF, but MJF's not the answer to everything. There's FDM, there's SLA, there's PolyJet. We run it all. And so, that's really what drove us was people would ask questions. And instead of just being like, I don't know, man, HP says this is what it is, and that's all I can do for you, we would actually go and do the test and prove to the customer, hey, I don't know what the HP thing says, but like, you understand what 900 pounds is, and you understand what a 1/2 inch threaded, fastener is, and this is what you get. And then that was like the thing that was an unlock for our customers, and it just kept rolling. So we're constantly doing content because it's the only thing that helps us really sell people that are skeptical.
I really like the latest ones. I think I watched like 3 or 4 in a row on like TPUs and design and different wall thickness and how it can change the like how spongy it feels. So
and that's all a direct result of people wanting to know. I get the call all the time. Hey, I need a Shore 50 C material. And I need it in a lattice structure, or I need it in a living hinge. And I go, that's great. I said, we could do a PolyJet part for you, but it's prototype only. It's not UV stable. It's not good with high heat. It's not going to hold up forever. It's strictly for prototype. And they go, well, this isn't a prototype. It's an end use part. Okay, well, we have a great TPU rubber material on the MJF machine, but it's 95A durometer. And they would go, oh, that's way too hard. And I go, well, hold on. Like, yes, it's hard, but if you design properly for it, you can make it flexible. It can be hard and flexible at the same time. It's kind of an oxymoron, but it's true. And so that's where that TPU test video came from, was exactly that, explaining to a customer how to design their parts to induce flexibility while the material is still hard.
Yeah. And so I'm going to get into a little bit in the weeds here. So you've got kind of your MJF machine. So do you run nylon and like the TPUs?
Yeah.
What's the clean out process like?
So we have 2 processing stations.
Oh, okay, got it.
Yeah. Oh, yeah. If anyone is like thinking they're going to get into MJF and they're going to hot swap materials on their processing station, that is a massive undertaking. You will burn $3,000 in material just trying to purge your machine out, and it will take you a day and a half. And even then, now that I think about it, HP won't even let you change it out yourself. You have to have your reseller come in and actually do the clean out and put the new material in for you. They won't even let you do it yourself.
Wow. Yeah, I got my start using an old DTM machine. So taking the powders out. So
I mean, that's the really sweet thing about these MJF machines, and why I saw when I first saw it, I'm like, that's it, because the printer itself is material agnostic. Yeah, you're going to have an hour of PM every time you finish a build, to get everything clean. But you pull that build card out, you do your 1 hour PM, you go from PA12 to TPU, and you're an hour to get between them. Versus the SLS machines, you can have some serious time in getting material switched over on, especially the older ones. That is a real unlock, and that's why I really like the fact that you can do that with an MJF machine. It makes it, instead of having to have a dedicated SLS machine for each of your major running powders, you can have one MJF printer, which I don't know what the list on a 4200 or 5200 is these days, but it's significant money. But like a processing station, you can get into a processing station, for $100K. And so now, instead of, $500,000 to have printers with each of your materials in it, now you might have $500,000 for a printer, and then 100K. And now you've got, essentially you've got all these materials, and you don't have that huge up. You still have a big money investment, but you don't have that $1.5 million worth of equipment. You might have sub $1 million worth of equipment. And technically, yeah, you can't run them all at the same time, but the MJF runs so fast that you can switch between them and still get your parts done on your customers' timelines, in our experience.
And as you have scaled, or people become more familiar with the MJF technologies, repeat customers, do you see them kind of expanding their portfolio of like, hey, we're actually thinking about doing production in this, or low volume, kind of beyond jigs and fixtures?
We have seen a real change in our business over probably the last year and a half. And I think that's also because we're getting more and more name recognition in the additive, industry. So I think that has something to do with it. But I really think that, production additive is here. Like, it has arrived. And I think that we are in for a very exciting, next decade, essentially, in production additive. You look, so like I said, I'm machine designer by trade, right? So I am always looking at, additive and thinking like, oh my God, like someone needs to automate this process, like unpacking builds or blasting parts or dyeing parts. Like when we got into this, and I'm like, everyone's like, get a freaking Econoline bead blaster chamber and get a crock pot that you fill up with black dye, and ta-da, you're in the additive business. I'm like, this is stupid. Like, why is no one automated this stuff? So literally with dye is a great example. I was so frustrated by the fact that like the two solutions were a crock pot with black dye in it, or like an $80,000 Dimension system with like proprietary dye cartridges. Like, don't get me wrong, Dimension, great people, great equipment, very German, like most German equipment. My opinion, wildly overpriced.
And over-designed. You could shoot a bazooka at it. And
if there was like a nuclear bomb that was going to go off, I'd jump inside one of those Dimension blasting chambers. It'd be like Indiana Jones in the refrigerator. Like, you ride that thing out in there. Great equipment. It'll never break. It'll live way longer than you. But anyways, so, we were to the point where I went to my machine design, one of my machine designers one day, and I said, listen, next time we have some downtime in the engineering department, I want to go on Craigslist. I want to get an old washing machine. Okay. I want to get a servo drive and just an Automation Direct PLC. I said, we're going to rip the guts out of this thing. We're going to hook a servo drive up to it, and we're going to put a high temperature pump on it and a holding tank. And I said, I think we could make a great part dyeing machine out of an old washing machine. And then I get a freaking call from my HP reseller, and they're like, hey, there's this new company called Gerbau. They're over in Barcelona, Spain. They make industrial laundry equipment, and they have a new dye machine. And I look at it, and it's a high temperature washing machine. If you go to a laundromat, it's a laundromat washing machine that they rebuilt for dyeing parts. And I'm like, that's it. That's what I need right there. And I looked at the price, and I said, you know what? For what you're charging, I'd spend the same amount to build it myself. I'll just buy it. And I'm seeing more and more of that. You look at the guys at like AMT, you look at their vapor smoothing stuff. And I keep watching those guys because I can see where they're going with like some of their concept stuff of like a fully automated MJF cell. And so, you look at that kind of development, you look at the advent of like MJF, and like you've got high speed sintering coming someday from Stratasys that's supposed to be in a very similar kind of field from what I understand, or a similar type of equipment. And then, you put all that together and it's like, okay, well now someone calls you and says, hey, I'm looking at, this little bracket piece, and I've got a feature in it that can't be injection molded, but by having that feature in it, it brings a ton of value to this piece. So I want to do, 25,000 of these a year or something like that. I think we're at a point now where that isn't a crazy ask. Like that's something that can absolutely be done. And I think that there's also, OEMs and end users, they're becoming more and more comfortable with the idea of an additively manufactured part. Because I think so many people, when they think 3D printing or they think additive manufacturing, they think of the MakerBot at their kid's school. And don't be wrong, nothing wrong with a MakerBot machine, but it's just people look at that and they go, well, that's not what I want. I run a real business. I do real business. I don't want a kid's toy. And I think that there was a mentality for a long time that 3D printing was kind of a toy or a prototype, okay? And I think that is really changing, especially as the demographic shifts in more millennials are in leadership roles inside of these companies. I mean, that's like my best customer base is going to the young engineers or the guys my age, in their early 30s at these companies. And, they had a MakerBot in college, or they're not afraid of 3D printing. And so when they're looking at a production part, they're open to the idea of it not being a machine part, an injection molded part, a sheet metal part. So I really think we're setting ourselves up for some really exciting times in additive production over the next couple of years. But it's here. It's not like, oh, it's coming. Like, no, it's here.
And my hope too is on the material side. I think that's the challenge. I mean, we always want more materials, but I've been frustrated with the price of materials. Have stayed the same.
So when I got into the SLA side of things, I will never forget when I was talking to Ross, when I was looking at acquiring his business, and I was like, what's raw material cost on something like this? And he's like, you see that 10 kg jug in the corner? I go, uh-huh. He goes, that's $2,000. And I go, what? And he goes, yeah, you have two choices, 3D Systems or DSM. And they're essentially in a cabal. So whether you go with Acura or whether you go with Next, you're basically paying the same thing. And so that was super, that was, again, another reason I got excited with the MJF machine. I can get whatever, 130 kilograms of PA12 for about $6,000. And, that's a lot of money, but when you look at how many builds we can get out of that box and how many parts we can get out of that box, it's really competitive compared to any other 3D printing technology that I'm personally aware of. And I just think like the prices are going to continue to march down because let's be honest, all those patents from the 80s and 90s are running out. And as those patents are running out, more and more of these startup machine builders and more, chemical companies, like everyone's starting, like you can see the rush starting to come in, BASF is coming in and, whatever, oh my goodness, Arkema and different, people that names you recognize from the, polymers and injection molding world. Those guys are starting to come in. And now we're starting to get those big economies of scale, where the big injection molders, they're buying polymers by the rail car, right? And that's where you get the big, the big discounts and stuff like that. And it's like, I don't think we're terribly far away from being able to do that same thing. And like you said, the diversity of materials, I would love to see it go faster. One of the things that's frustrating about the MJF is I wish the velocity that materials were being released was a little bit higher. There was a little bit of, I think, an overpromise, underdeliver. I don't think they maybe realized how difficult it was going to be to get some of these things to work. So, it is what it is. But I think that, anytime there's new materials coming onto the market, or even like FDM, like, with like, PEEK or PEKK, different like kind of super polymers. Like forever it was like Altem, like that was the best you could get. But now there's all these other things that are coming online. It's like every time I'm like at IMTS or any of these trade shows and I walk by the DuPont booth, I walk up to those guys and I go, do you know how much money you could make if you can 3D print Delrin? If you can figure out how to print POM, everyone will just be like, shut up and take my money. Like and they're like, oh, it's not that easy. I'm like, you're DuPont, put some people on it. I bet you could figure something out. So yeah, I'm with you. I think, materials have a ways to go, but it's a lot better than it was even a couple years ago.
So as you've been growing your kind of 3D printing business, how do you find the people to get your team to kind of operate the machines? Like as kind of a business owner, when a lot of people that listen to the podcast are thinking about maybe exploring 3D printing as a career or kind of exploring the space, like what do you look for in someone that will work for you, work in your shop?
The answer that I'm going to give is tailored to the size of business that we are. So in total, there's 8 of us here. So myself and 7 others, and we're distributed between the additive and the engineering side of things. So we're a small company, and in a small company, being willing to do whatever needs to be done to get the job done. There are days where, all hell's breaking loose. I'm cleaning the MJF machine. I'm packing up boxes. I'm down there blasting parts. Like it's not, when I'm hiring someone, it's like, you know what, man, you're not going to sit here at a desk all day, answering the phone and writing emails and looking at applications. At a business of our size, you have to do that, but you have to also be willing to, hey, go throw on some crappy clothes. We've got an SLA machine that just blew up, and we gotta get some resin on ourselves to get this thing put back together. So we're really big. When I'm hiring, I'm always telling people, like, here's your job description, but here's the other half of your job description, because this is just what we do as a company. So this is what you're being hired to do, but this is the stuff that you may be called on to do at any time. And that goes from me all the way down to, the high school intern that I keep around whenever I have one available. You got to be willing to do the work. And that is one of the things that I've run into a little bit, is some of the guys that are, coming out of college and they're a little bit precious about themselves and the fact that, well, I've got a mechanical engineering degree. What do you mean I need to blast parts? It's like, dude, you want a paycheck or not? Like, I'm not here to like ruin your life, but like, if this has to get done, you have to be willing to do it. So that's always something that I'm looking for. Is I'm looking for the guy or the girl that is willing to do whatever needs to be done to make the customer happy and to get that customer to come back to us. Because every customer counts. We live and die by the fact that we have good repeat customers, and sometimes taking care of them means going outside of your job description. So that's important to me. Education is not nearly that high on the list. I've got people here that have a high school education. I have people here that have a bachelor's. I have everything in between. Education's great, but it just because maybe you only have an associate's, or heck, maybe you only have a high school diploma, but you know what? Like if you can do the job, additive is such a wide open industry. It's so young, relatively speaking. I mean, you look at like the foundry industry. I mean, that was like biblical times. There were foundries. I mean, like that thing's been around forever. So I mean, you look at additive, it's like the late 80s. Essentially, we got our start. Like we're in the infancy of this industry. And so, I mean, I've got guys here where, on paper, they look very, average to below average, but you put them into these scenarios and they just crush it. And so, yeah, I think if I was giving advice to someone who was like coming out of high school and like, I want to get into additive manufacturing, like, look, if you want to go to an engineering school, you want to get a mechanical engineering degree, like that's great. That's valuable. But if you're like, man, I really don't want to go to school, or I want to get my start and then maybe figure things out, like go find your local additive manufacturer and be like, hey man, do you need someone to blast parts? Do you need someone to, sweep the floor? And I guarantee you, if you go in there and you show that like you're diligent and you're hardworking, like sky's the limit, because there's no book, there's no class that teaches you additive manufacturing, at least not that I'm aware of. And you can get exposure to it in college, but it's not like a mechanical engineering degree where like, there's a very laid out path that you can go down to get to something like that. With additive, it's kind of wide open, so you can kind of make the path however you want to. So, whether you're, a complete rocket scientist, you want to go work at like one of these crazy metal printing facilities that are building SpaceX parts, or, you want to come work for some good old boy like me in a small town America who's just cranking out parts for all kinds of different industries, you can get in. It's the wide open opportunity is here. You just got to come grab it.
Sure. And so going into 2021, we're at the start of the year here. Kind of what are you looking forward to in the coming months?
Hopefully a return to normalcy. I'm a sales guy at heart. I love sales. I love talking to people, being around people. And, the other reason that I've always done the videos, but in 2020, I couldn't do cold calls. I couldn't do lunch and learns. I couldn't go to AMUG. I couldn't, the only thing I went to last year was SolidWorks World. And that was like a week before COVID really hit in the United States. And that was the end of it for me. And so, I was left to like, well, I have to reinvent what selling looks like in 2020 because it's not the way I've been doing it for the last 10 years. And so thankfully, I've lucked into having the skill set to, be a little bit, savvy on website design and making some videos and content and stuff like that. And that worked really well for us in 2020. But in 2021, last week we had our first lunch and learn. I had one of my customers call me up and he's like, dude, we got to get it. I got to get my engineering department into your office. I want a full tour of your facility. And I want you, I do these things called the all killer, no filler lunch and learn. It's not a sales pitch. It is a hardcore design for additive manufacturing hour. And I tailor it to whatever group I'm talking to. So in this case, it was a machine builder. So it was like hardcore, how to design the type of stuff that you as a machine builder are using, how to design it for additive manufacturing. And so I'm really looking forward to in 2021 being able to get back to doing that again, because I just miss being around people, to be honest with you. Like I have a great crew here, but I'd like to see some other people too. So that, and then, last year was stressful to say the least part as a business owner. I look at my employees and I don't just see them. I see 5 children that I'm putting food on the table for. I see mortgages, I see car payments. And, in end of March of last year, like all of our engineering work got canceled. Our printer was literally all of our printers were just sitting here. Like no one was even submitting RFQs. And it was terrifying for a couple of weeks there in March, because I was like, what am I going to do to provide for these people? Because essentially the buck stops in this office right here. Like if, I'm the one that has to keep things going, I'm the sales engineer. And so, thankfully we pivoted quickly and got into some PPE and got into a bunch of hand sanitizer dispenser work, and it worked out okay. But hopefully not having to do that again this year. I would just like a normal year with just normal problems, no pandemics. I want to see people. I'm a simple man. I just want simple things.
I think we can all agree with that. So, yeah. Paul, I really appreciate the time. And good luck with everything in the coming months. And hopefully, maybe I'll see you at AMUG. So,
yeah, I'll be there. I'll be there, man. I think I'm going to be. I don't know if it's been accepted yet, but hopefully I'll be presenting at AMUG this year. So, perfect. But yeah, Mike, thank you so much for this opportunity, man. I really appreciate it. And anyone who's watching, hey, if you want to, talk to me or see any of the content I'm putting out, Paul DeWys on LinkedIn, PaulDeWys. Send me a connection. I'd be happy to connect with you. If you want to shoot me an email, it's Paul at Forerunner3D.com. So that is Paul at FORERUNNER, the number 3 and the letter D.com.
Awesome. And we'll post everything on the links when we post this out. So we'll link to videos, all the awesome content as well. So
thanks,
appreciate
Mike.
it.